Hello, Pratham. Am I audible? Hello, Pratham. Is it
Yes,
audible to you or not?
yes, sir. Can you hear me?
Hello, hello.
Can you hear me, sir?
Yeah, I can hear you.
Okay.
So, Pratham, in the last class, what we discussed, we have discussed a relation between, I think, electric field and voltage, right? And after that, we completed one topic, which is a continuous charge distribution. Over that, we completed charge conducting sphere, right? Potential over a charge conducting sphere. Okay, so if you have any doubt till here, you can let me know, or I can move to the next topic.
No, sir.
Okay. So look, in the last class we covered. Okay, fine. So in the last class, what we covered, we have covered charge conducting sphere, right? Now what we
Yes,
are going to do, we are going with charged non-conducting sphere. Okay, non-conducting sphere. So just a second. First case I'll be taking case of hollow non-conducting. Okay, hollow non-conducting sphere. So I said it is a hollow, okay, in non-conducting sphere. What does it means? You will be having a spherical surface. All the charges will be on the surface, right?
yes,
So we'll be taking in two cases, two different cases. Let's say the radiuses are okay. So I will try to calculate potential for two cases. First is I'll be taking any random distance r, which is greater than or equals to r. Okay.
yes,
So how it will look like? Uh, you know that dv is equals to negative e times of dr, right?
yes,
For r greater than equals to r, what is electric field? It is equals to how much? Kq divided by r. Is it?
yes, sir.
Okay, so I can put it over here. So dv equals to kq divided by r and dr. Okay, it is square. Okay. So when you integrate it, you will be getting kq minus 1 by r. Any doubt?
Yes.
You have any doubt?
No, no.
No. From where to where I am going? I am going from radius r to some random distance r. Understood?
Yes.
Okay. Or I can say that I'll be like we are looking for any random radius. So assume it to be the potential to be the r. Clear?
Yes.
So whatever you will be getting, potential will be nothing but minus this negative will cancel out. So you'll be left with kq divided by r. Is that clear?
Yes.
Okay. One more thing, I integrated both sides now, so this should have also been integrated. Okay. Now I think it's fine. So this is potential for R is greater than 1. Now I have to calculate for R less than R. Okay. So again, what is the value of electric potential? dV is equals to minus 0 to R. Okay, wait, just a minute. E dot dr, right?
Yes.
Okay. So wait, it should not be dV. There also it should not be dV. I just made mistake. So this is integrated portion. Now it's fine. Okay, this is one thing, right?
Yes.
Okay, now I have to calculate potential inside. What is potential inside? So how I can calculate this?
We did this in the last class, right?
Yeah, we did the same thing in the last class. So when you differentiate it, you will be getting dv equals to minus e by dr. Now what happens is, for r less than this, what is e? E comes out to be zero. Is it?
Yes. Yes.
Okay, so this equation is this: for e just less than r, for r less than r, e is equals to zero. Okay,
Okay.
and r equals to r. What is the e? Kq divided by r square.
Yeah.
Okay, and potential what you have here, kq divided by r. Clear?
Yes.
Okay. So if dv by dr, dr equals to 0, means v final minus v initial equals to 0. It means v final, basically at v final at some distance r equals to vr. Is that clear?
Yes.
So I can say v at different value is comes out to be kq divided by r.
Okay.
Understood? So again,
Yes.
if I make a graph, so for this the graph will go like this. Center, go this side r, this side again r. At this axis we are showing the potential value. So this is v. Here we are trying to show axis. Basically, what is the value by the distance. So you know when you are inside the circle, your potential is constant, right? Let's say this is the value kq divided by r. After this, if you go this side, it will be decreasing. If you go
Yes.
this side, it will be increasing. Okay.
Yes.
Exactly, it won't touch zero somewhere around infinity, which it is touching zero. So I can say this is r, this is minus r. If you see carefully, three cases, whatever we are studying, whether it's electric field potential, for when it comes to uh, for solid, I can no, for conducting solid or hollow and non-conducting non-conducting hollow. For these three cases, values remain same, right?
Yes.
If you see carefully in potential for all these three cases, outside you have potential electric field as kq divided by r square. Potential you have kq divided by r.
Yes.
Inside the circle for all these three cases, e goes equals to zero and v goes kq divided by r as a constant value, right?
Okay.
Okay. Now there is a special case, basically which is solid non-conducting. Why this goes special? Because this is the only case where you have charges present even inside the circle, even in the core of it. Okay, solid non-conducting sphere. Now, how we should do this part? Okay, how we should calculate for this part?
No idea.
No idea, right? Look, let's say you have a bigger body. Charge this. Okay, if you could remember when we were calculating for potential electric field, let's say I had told at center I am going at distance, I am taking a sphere. Okay, and I'm trying to calculate using this. So what happened now when I was calculating electric field due to this charges electric field at this, I used to calculate E equals to kq divided by r. Okay, whatever the radius of this, right? Because all the charges, and due to all the charges, what is the electric field here? Okay, and due to these portion, these this reason comes inside, right? If you can see this reason comes inside, so I can say due to this there is no effect inside the electric field, right?
Yes.
But here case goes different. What is different here is, if I calculate potential due to this thing, what I am going to get at the surface, it will be k q divided by r. Okay, what is whatever it is, and due to this portion, whatever the charge you have, okay, whatever the charge you have outside, let's say q dash, and whatever the radius you have, kq dash by r. Understood? Because
Yes.
due to sphere, the potential inside, even the electric field is zero, even I assume it is hollow, due to the outer portion the charge inside goes constant, electric potential goes constant, right?
Yes.
Okay. So that is why this case goes bit different. So let's remove this and let's solve this problem. Okay. So remove it. But we have got our task easy by doing one thing. Okay. Look, first I'll be calculating outside. Okay. Outside, it again. It is very easy part. This is the sphere. Okay. Whatever the charge you have, you can call it as q. So outside you can easily calculate, right? What is the potential outside?
KQ
Kq
by
divided
R.
by r, right? The
Yes.
main task comes up when I'm calculating inside. Okay.
Yes.
So inside, what it will be? Look, right now, if I'm inside, okay, what should be potential? Now I know V equals to minus E dot dr, right?
Ye- Yes.
Do I know the value of electric field inside?
Yes.
What is that? E
KQ
equals
by
to
R.
K Q R divided by R cube, capital R cube, right? This is
Yes.
for R less than R, okay? I can put this value here also. Let's put. So you will put V equals to minus KQ R divided by R cube and dr. Okay, now I have to integrate. From where to where I am going to integrate this?
From 0 to R.
Yeah, 0 to r. So look, V equals to minus K. Let's take KQ and all the constant thing outside. Yeah. Now from where to where I am going? I am going from inside to outside, right?
Yes.
Basically, it's up to you from where, like it's up to you from where you want to go. Okay, so I can say that I want to go from, okay, here it also take, and I have, okay, you have two options. Either you can go from outside to inside, or either you can say I am going from outside to this point. Okay,
Okay.
okay, wait, let me take it. Look, this was the center, right? I wanted to calculate potential at this region at distance r. Okay, so for two options, either I can say, okay, I'm going from here to here, right? And this is the easiest portion, because if you see carefully in the previous cases also, I was going from surface to inside, right? What is the value from surface to inside?
Okay.
Understood this part? Look, if you see
Yes.
here also, I was comparing. When I was solving this part, I went from outside, right? I took S as my surface in the initial point, right? So here also I am going to say, from where to where I am going from Vs to V somewhere inside. So it goes as V minus Vs equals to, what is the KQ divided by R square? R cube. And what is the value here? Again, I told I am going from some radius outside R, exactly R, to inside. So I can say I am going from this to this. Okay. So if you solve this one, what you are going to get? Minus KQ R square. Keep it like 1 by R square. R to R. So minus KQ 1 by R square minus 1 by capital R.
Yes.
Understood this part?
Yes.
Okay. Now what is this? What this value comes out as? Okay, one more thing. There's this part. Okay, so keep it clear itself. Wait. We did mistake here.
Yeah.
Right? We have done a mistake. Remove it. Let's see. R was here, na? And it was dr. Okay, so K, it will become how much? KQ divided by R cube 1 R square Okay, here you will be having this. Is that clear?
Why is the 2 there?
Okay, integration of r dr is equals to half of 2 r square, right?
Okay, yes. Okay, okay.
Got it? So I'm going from r to capital R, so you can write the final thing as kq divided by 2r cube r square minus r square. Understood?
Yes.
Okay, now one thing also is left. What is vs? Is it like vs is also left? Huh? If you see
Yes.
carefully, can I rewrite this thing? This Okay, what is the value of Vs? Let's write. If you see Vs is nothing but the potential at the surface. What is the potential at the surface? That is KQ divided by R.
R.
Okay, let's go with this inside. So if you see KQ divided by 2R, and I'm taking look, it has 3R square. So I'm writing it as R and R square, and I will take this to inside. Okay,
Okay.
so it will become R square divided by r square minus 1, because you can see r square is there. If one r square goes inside, it will get cancelled. Okay,
Yes.
so it goes like this. Now I will take this to the right hand side. So v, what do you become? Kq divided by 2 by 3 r square by r square minus 1 plus kq divided by r. Take q, this portion common, okay, from whole thing. So you will be getting kq divided by r common 1 by 2 r square, r square minus 1 by 2 plus kq. Is that clear?
Yes.
No, no, wait. I took this as common, so it becomes 1. Is that clear? Take a look if you have any doubt.
No, sir.
Everything is fine now?
Yes.
Okay.
So, but I think
Yeah, what happened?
when we open the bracket, we don't get the plus KQ. We will get KQ by R.
Oh, which one? Which one?
So, in the last, when you just took the KQ in the bracket, in the
Wait.
second step, the KQ is outside the bracket, right?
Yeah, this one. No?
No, below this.
Okay, here it is outside the bracket.
KQ is outside the bracket plus KQ you have written.
KQ is okay. Yeah, look, this thing is outside the bracket. I took it more outside. Okay, so it becomes something like this thing,
You took
isn't
the
it?
KQ common, right?
Yeah, it was R here, right? KQ by R was there, na?
Acha. Uh-huh.
Clear?
Yes.
So that's the thing it was. Let's move it, make it R. Now it's fine.
Yes, yes.
Okay, now if you again solve this one, what you are going to get? Just
We
take
are
whole
just
LCM. Just to take whole LCM thing. So you will be getting something like this.
plus
Okay,
R.
R square divided by R square minus 3 by 2. Okay. Okay, not 3 by 2, you can say 2 is also there. So it becomes this thing. And you can call it as something. This 2 is there minus 1 by 2. Now is it fine?
So shouldn't it be plus 1 by 2?
Okay. Which one? Wait, just a minute.
Plus 1 by 2.
No, I think this is fine, right?
Yeah. It's 1 minus half.
Look,
Should
this will becomes minus half. No? So this is what I have written.
so that will become plus half.
Okay, okay, fine, fine. You are saying for plus half, no? Yeah. This is plus plus, it will become plus half.
Yes.
So whatever it is here, we can
Yes.
rewrite the same thing as what we can
KQ
end
by KQ by 2R.
KQ by 2R. Makes sense. KQ divided by R. And should I take R square outside?
Yes, you can.
Hmm,
Yes.
we had some mistake, I think, or wait, let me check again. This equation was there. One R square I went with inside. Okay, this thing I took like this. This is again I took like this. So this equation I have got right now for this. Mm,
kq by 2 r cube r square plus capital R
uh,
square.
yeah, I think. Okay. Oh, wait. Okay, fine, fine, fine. This is fine actually. So we can take two as a common also, no? Outside.
Yes.
Okay. So it becomes two. Whatever equation I have, r square this plus one. I'm left with, and okay, I can rewrite the same thing as what vs by two r square by r plus one. Understood?
Yes.
Any doubt?
No.
Okay, that's fine. Mm, I think some mistake is there. I'm not sure whether it is in the calculation part or where it is, but I can think of it one mistake over here. Okay, so it is. Hmm, okay, fine. So I took this R outside.
So the negative sign in the second step, I think.
Negative sound sign where?
In the second, from first step to second step, it
Mm,
should be
okay.
minus kq by 2r.
Here was minus one, right? Okay,
Yeah.
here minus three was there, na?
Yes.
Okay, okay. I think yeah, this was the mistake we did. Okay, we should have kept this negative sign along with. So put it negative, 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 negative. I'll put the this thing finally inside also. So we'll see this part. I think some calculation mistake or something I did here. Okay, look. What I want to say, na, the expression should come out something like Vs divided by 2. Okay, it should be 3 minus r square by r square. Okay,
Okay.
why this part? Look, if you put this, it will become Vs divided by 2 minus 1 minus r square by r square. So that's why I'm saying I have did some mistake here. Okay, in a
Okay.
calculation part itself. So yeah, that's what I had to think of it again. Hmm, this should be the final expression. I think. Okay, let's do one thing. Let's do one more topic. Okay, at the last of the class, I'll check this part again. Okay.
Okay.
Yeah, it will be better option. I think we can do another part which is potential due to a ring of charge. Understood?
Yes.
It will again the simple thing because we have already done. So I'll take this part and it will get covered in the meantime. A ring charge. Again, it's an easy thing. You just have a sphere, basically this ring. There is a point we have to calculate potential at this point, right?
Yes.
You already know what is electric field. You know net electric field is in this direction,
Yes.
right? And what is the value for that electric field?
I don't remember.
Okay, you don't remember. That's fine. Okay, even I think in this part now we don't have to do much. I'll just go with the normal potential. Okay, let's say this is a smaller portion I'm taking. What is the potential due to this smaller portion? You know it will be nothing but because look, potential doesn't depend upon charge, right? So I can say potential due to this smaller portion is nothing v dv, right? And what it will be k, whatever the charge it is divided by the distance. Let's say this is r and this is your x. So what is the distance? R square plus x square.
Yes.
Okay, now what I have to do, I just have to do it and I have to integrate it whole. Okay, so if you integrate this, k dq divided by r square plus x square under root. Integrate it. Okay. When you integrate it, what you are seeing, you can see that just I'm adding more charges. Okay. For each charges, the direction and like the distance is remains same. So I can say that it will be nothing but r square plus x square dq. Okay, so finally we will be getting potential equals to k q divided by r square plus x square under. Is that clear?
Yes.
You can see it is very easy part, because look, in potential we don't have to look for the direction all. Okay, for each charges the distance is same, so you can just integrate the charge itself. Clear?
Yes.
Okay. Okay, you can also say if my again it's the same thing. If my if x is much greater than r, so you can also write this as kq divided by x. And now what it looks like? Isn't it look like you have a bigger charge q and you are calculating potential at distance x, right?
Yes. Yes.
And it will be possible if you had a ring charge, if you go very far distance. Okay, so this will seem like a normal charge itself.
Yes, sir.
Okay, so if every like if wherever place you are having, and if you see, okay, charge is very smaller, you can say ring is very smaller, you can treat that as a single charge particle. Yeah.
Yes.
And I'm going to add this part. Check if I print this. Why there's a margin from left? Hmm. Maybe this, if I do it like this, big margin. Now
What happened,
it's
sir?
nothing. I was just checking because I have to share it. So I was just checking like will be getting clear pages or not. Okay, now it's fine. Okay, all right. Now another thing is charged ring. Okay, charged ring. Let's go for the charge ring also. One more thing. Instead of doing just with the charges, we can also go with the surface charge density. Okay, or linear charge density. So if you see carefully, in this case, if I ask you what is linear charge density, what it will be?
No idea.
Okay, no problem. Let's calculate for the disk. Let's calculate for the disk. Okay. If I have a charged disk, then how we can do this? Look, I have a bigger disk, okay, and I have to calculate potential due to this disk at some distance x. Understood? At this point. Now I don't have any option, but I know one thing. If I can carve out smaller rings, okay, because I know what is the potential due to these rings, right? I know this part.
Yes.
So let's say the total charge density of this. I'm saying the area charge density is nothing but sigma. Okay. So
Okay.
you know that sigma is nothing but the total charge q divided by whatever the area. I can say pi r square. It will be also equals to dq divided by the area of this strip. Can I say this part?
Yes.
And what is the area of that strip? Let's say this was my disk. Okay. Bigger disk was this. I went from center to some distance smaller r, and I carved out a strip of some width, you can say dx dr. Okay, understood this thing?
Okay.
So what can be the area of this strip? You can see if I take this strip outside and cut it from here and open it, will it look like this?
Yes.
What is the width in this case? Dr. And what will be the length? You can say whatever the parameter is, it will be length, so it will become 2 pi r.
To
Is
pi
that
r.
fine?
Yes.
Let's remove this and put it over. So dq divided by 2 pi r dr. So you got to know that dq is nothing but k pi r square 2 pi r dr. Cancel. So dq is what I can write. Okay, also one thing, instead of putting in the charge format, because I have given you sigma, right? So don't do this. Don't take this part. Because if you know the value of sigma, you can directly put that. Take the dq in the form of sigma 2 pi r dr. Is that clear?
Yes.
If ever you want to put the value in the form of charges, you can directly put the sigma equals to q by pi r square. Okay, you will get the final answer. So that's why I'm going with the sigma. Okay, I know this part. Now what I have to do? I know what is the dV. What is the potential? So you can say potential dV is nothing but k dq, the total charge on this strip, that is dq divided by, if I say this is the radius r and this is the distance x, so what will be the value? It will be x square plus r square under root. Is that clear till now?
Yes.
Now what I have to do, I had to integrate it. Integration means to say, right now I have taken this strip. Okay, I want to take, I will be going from zero. Basically I'll be taking some one strip here, another strip here, another here, so I'll be going from zero to r. Clear?
Yes.
So I just have to integrate it. Before that I can put the value of dq, so it will become k lambda 2 pi r dr divided by x square plus r square. You can see I have now single variable r. Okay, this x is basically the distance where I'm taking. Okay, I can integrate it. If I integrate it, I'll be having, um, let's take all the constant outside, sigma k 2 pi outside. I'm left with r dr divided by x square plus r square. I remove this, r x square plus r square. Okay, one more thing, keep 2 inside. Okay, 2 I am putting inside because I need to do integration. Okay, so this is what, if you do integration whatever, you will be getting v finally. You know how to integrate this part.
Yes.
Okay, so what I can do is, for integration I can say that my x square plus r square is nothing but u. Okay, so if what it will become, I'll be getting r 2r dr equals to d. Is that clear?
Yes.
So you can see 2r dr, I can rewrite this thing as du divided by u, and
So,
lambda.
how is two RDR U? Do you?
Wait, what?
I didn't get that two RDR is equal to DU.
Okay, look, in this equation, what is the variable? Only r is variable, and I have taken this equals to this whole portion, so this also
Yes.
becomes variable. Is it?
Yes.
What I'm saying, differentiate the whole equation with respect to dr, you can say, and du, whatever you want to say. Okay,
Okay.
so whatever, it's up to you. Let's say I'm calling it with respect to r, so it will become dx square divided by dr. You can see, this is
Yes.
a constant part, right? X is a constant, and because I'm going at some distance, so it is a constant, so I can say this goes to 0.
Zero.
Plus I had
Two R.
dr square by dr, so it will become 2r, right?
Yes.
Because it will be dr by dr, so it comes out just 1. Okay, so it doesn't make sense. Now what you can do, equals to du by dr. Okay, I don't have
Achha,
any
yeah.
relation for this, so it
Got
becomes
it.
like this. So you can see du becomes 2r dr. Make
Yes.
sense? You can do another way also. Another way is that if you differentiate it with respect to u, so you can say
Okay.
this goes route. Okay, if you are
Okay.
left with this, so du, what it is, dr square by du, it will become 2r dr by du, but you don't have any integration for this, so it is fine. du by du becomes 1. Clear?
Yes.
So if you put this whole thing, you will be having dr divided by du equals to 1. So again, you got the same thing. Du equals to 2r dr. Understood?
Yes.
Okay, let's remove all this thing. Look, wherever you see the equation something like, okay, yeah, wherever you see something like this, you have below this one, and even if you have a single r naught, you don't have to figure out, just do the same method. Okay, for 2 I had a 2 here, like this 2 was present in the equation, so I was able to do. If 2 is not present, then how you can do? Just simply multiply and divide by 2. Okay, now you can take this 2 as outside, solve this. Understood?
Yes.
Okay. Now I can remove this. So v becomes lambda k pi. I think pi is also there. K lambda pi, and this is fine. So you have du divided by, okay. So again, if you integrate this out, they will be getting this pi, and it will become minus 1 by. Clear?
Yes.
From where to where we are going? From 0 to r I am going. So you can again write this as lambda k pi. Okay, put the final value of u. So what was the final value of u? Okay, we did one mistake. Mistake was, it was this. Clear?
Okay. Yes.
Now fine. Okay, now I'll just tell you one more thing. If you do like I told you this part now, if you do this method, this is also fine. But finally, when you are putting the value instead of this u, you have to put this thing. Okay, clear?
Where?
But better than, okay. Wait. I'll just
I
do
I,
this
I
part.
wouldn't see.
Wait, I'll just teach this part again. Okay, because integration now it will become changed. Can I do integration both side? Like, can I do squaring both side?
Yes.
Okay. Root square. Not root. If I do this, it will become x square plus r square is equals to u square. Again, differentiate with respect to whatever you want. Okay. So you'll be
Yes.
getting something like 2r dr equals to 2u d. Is that clear?
Yes.
Okay. What is look? What I have to do here is I need this part, right? You can see instead of this part, I can put this thing, right?
Yes.
Let's put it lambda k pi divided by 2u d
D.
divided by what I have nothing but u square. Clear?
Yes.
Cancel out, cancel. Lambda k pi 2 du by, understood?
So shouldn't that be only
Okay,
root x square plus r square was u?
wait, yeah, I think we made mistake. It was du, right? And the whole thing was du itself, so I can write it like this. Clear? I hope now it
Yes.
should be
Yes.
clear.
Yes. Yes. Now it's right. Yeah.
It's clear. And now we can solve this one. You can see lambda k pi. Okay, when you integrate it, what it will become? 2 is outside. Integration of du will result u. Clear?
Yes.
So whatever I have got this. Now I can put the value from where I'm going. I'm going from 0 to r. So you will be having 2 lambda is, put the value. What it is?
Root x
K.
square.
Yeah, it is x square plus what is the other part?
R square.
Yeah, r square.
Whole
Okay,
root.
and from 0 to r. Okay, one more thing. Instead of going from 0 to r, I can say that, okay, I am going from r to r1 to r2. So what you will be getting? Okay, one more thing. This u is equals to under root, right?
Under root. Yes.
Yeah, so remove it. 2 lambda k, put it under root. And this was pi under root r square plus x square minus x r square, uh, minus r square plus x square. This is R2, this is R1. Okay,
Okay.
what does this mean? Let me tell you. Look, if you see, I took the complete charge disk, right?
Yes.
Just assume if I am saying I am going from R1 to R2, it means to say I am not taking a charge disk here. I have taken another case. Okay, I have taken another case. This, if you have a concentric like this ring, you have given this kind of ring right now. Understood my
Yes.
point? This part is hollow. This is a hollow part. Okay, you have
Yes.
given this kind of ring. It means you are going from radius R1 to finally R2. Now make sense?
Yes.
If you are saying okay, my R1 is 0, when R1 becomes 0, it means you have a complete disk. Understood? From here to here,
Yes.
it means you have 0. If you put that R1 equals to 0, R1 equals to 0, then what you are going to get 2k this pi R2 square plus x square minus, you will be only left with x square, and x square under root, it will become x. Clear?
Yes.
So this is what your equation will left. Okay.
Okay.
And now what you can do is put the value of k. Put the When you put the value of k, 2 lambda, k is nothing but 4 pi epsilon naught. Pi is there. You can see pi got cancelled, 2 to 2, and you are having r square plus x square. Okay, this capital R you can call it as main R because this is the final radius, right? So minus x lambda by 2 epsilon naught under root r square plus x square minus x. Clear?
Yes.
Okay. So this is what the main equation looks like, and you can put the mod also if you want. If you don't want, okay, okay. So I think now you understood. If you have three cases, one is ring. If you have a simple ring, you can follow the V equals to K Q divided by whatever the equation, and this distance x r, r square plus x square under root. If you have a disk, complete disk, apply this formula. If you have concentric kind of thing, like this is radius r1, this is final r. So you can add one more thing here, uh, under root r1 square. Just this part you have to add it. Is that clear?
Yes.
So three cases for the ring we have completed here. All right, one more idea I can give you. If you take this as common now, what will happen? If you take this common, you'll be getting something like r square plus x square, and you can also call this as, okay, this is x, this is r square plus x square. So you can call this as cos theta. Complete. If I'm saying this is my theta angle,
Yes.
you can come. You can also call that the whole thing comes out as cos theta, okay? And this will come outside. So I think you can do these kind of conversions on the basis of questions. Okay.
Yes.
Maybe I can remove. All right. So look, 3 to 4 topics we have covered in this class. Okay. If you have any doubt, let me know, or I can just go with the first thing where we have some doubt. Okay.
No.
Let's clarify this part. Okay. I think till now everything's clear, right? I don't see any mistake here.
Yes.
R2 DR. This thing was still there. Okay. So if you keep outside, it will look like this. Something, some difference is there. I'm not sure what. This is, it is fine, I think. Okay, how I got cube here? Okay, cube was in the formula itself. So when I did this part, I got one extra, taken to outside, took this from here to here. Okay, so it becomes positive going to that side. If it is goes going that side, it becomes positive. And here after, what I can say, it should become something. Am I not able to see something is here, or is it like this itself? Okay, fine, fine, fine. Look, look, look. Um, where is it? Can you see this part? When I took this inside, what happens? What I will be getting? I'll be getting KQ2R 1. I think it is R square by R square. Is that clear?
Yes.
Now what happens? Here, when I have not included this part, right? Earlier I didn't include it. Okay.
Yeah.
So if you see now, if I take this inside, this thing will become positive. Okay.
Yes.
If this becomes positive and this becomes negative, it will become negative. Finally, this will be half plus 1, it will become 3y. And this is
3 by.
negative.
Okay.
Okay, here negative 3, negative 3. This is, okay, this is 3 and that thing, and I can remove this part. Any doubt?
No, it's fine now.
So things have been cleared. But just one sign convention problem was there, which we ignored earlier.
Yes, sir.
So that's all for the day. Okay, potential part I think we have covered. Some one or two more topics are there. Basically, application-based topics are there. In the next class, I'll be just teaching one application more on the charge ring part, and work done in rotating an electric field. Okay, rotating an electric dipole in electric field. After that, I'll start with the capacitance. Is that clear?
Yes.
Okay. So yeah, that's all for the day. If you haven't doubt, let me know, or else we can end the session.
No, sir. Bye, sir.
Okay. So goodbye.